So in this section, it's kind of a hodgepodge a little bit, but the first thing that we're going to talk about is something called a difference quotient. So whenever you're asked about finding the difference quotient for a given function, that means you're being asked to find this ratio, f of x plus h minus f of x divided by h. And notice that for that ratio, h can't equal 0 because you can't divide by h. You can't divide by 0 if h equals 0. So that's that restriction. So some of you guys, if you've done this before, then, just go ahead and do it if you're comfortable with it. If you're just getting used to it and you're learning it for the first time, I like to break it into 3 steps. So you'll see a part A, B, and C. When you go to do these in the homework or on a test or something, it'll just say find the difference quotient and you just give me the answer. But I kind of recommend as you're getting started just breaking it into these 3 chunks. So the first chunk is finding f of x plus h. So that's part A. Second chunk is then taking that f of x plus h from the first part and then subtracting f of x. So that's your numerator in part B. And then part C is taking that numerator and dividing it by h, and that'll give you your final answer. All right, so for number 1, it says for the function f of x equals 3x plus 5, find the difference quotient using the 3-step process. And ultimately, the goal is just to find the difference quotient, whether you break it into 3 steps or not. All right, so I want you to notice what this function notation means. F of x equals, so f of x, that's your input, equals 3 times x plus 5. So if we had like f of 2, for example, you guys all know that we would take 3, multiply it by 2, and then add 5, right? And that would be 6 plus 5, which would be, in this case, 11, right? Down here in part A, we want to do f of x plus h. F of x plus h. So where we have x in our original function, that's going to get replaced with parentheses x plus h. Just like f of 2 was 3 times 2 plus 5. Down here where I have f of x plus h, this is going to equal 3 times x plus h in parentheses plus 5. So I'm just going to put that x plus h in a different color. So whatever I have inside my parentheses f of x plus h goes inside parentheses there. I replace my x with parentheses x plus h. And now I want to simplify this. So I'm just going to distribute the 3 throughout the parentheses. So this gives me 3x plus 3h, and then I bring down the plus 5. So this stuff is just f of x plus h. And if I could combine like terms or something, I would, but I can't. So I stop here. All right, so moving on to part B, we have f of x plus h minus f of x. So this will create our numerator and our difference quotient when we pull it all together. So this part, f of x plus h, just comes from part A, so I'm just going to copy this down. 3x plus 3h plus 5. And then where it says minus f of x, I know that f of x, my function, is this guy, 3x plus 5. And if I want to subtract 3x plus 5, then I need to subtract the entire function. So I put minus and then parentheses 3x plus 5. So when I carry this down, I have 3x plus 3h plus 5. Then I distribute that minus sign to get minus 3x and minus 5. And again, I want to see if I can combine like terms. And in this step I can. In part B I can. I have this negative 5 that cancels with this positive 5. Negative 3x, positive 3x. So after everything cancels out, all I have left is this 3h term. So that's my numerator in my difference quotient. And then for part C, I want to write f of x plus h minus f of x. So that's just going to be 3h from the numerator. And then I need to divide by h. So divided by h. And here, 3h divided by h, those h's cancel. So difference quotient is actually just a 3. All right, let's try this again for number 2. So now we've got this quadratic function, which means stuff's going to get trickier. So I've got f of x equals x squared plus 2x minus 1. And again, notice that in my function notation for f of x, I'm going to take x and square it, and then plus 2 multiplied by x, and then minus 1. So now for part A, when I want to find f of x plus h, f of x plus h will be x plus h squared plus 2 times x plus h minus 1. So anywhere x appears in my original function, I'm going to replace that with x plus h in parentheses, x plus h in parentheses. So first up, x plus h in parentheses squared. I want to FOIL that out, multiply that out. So this is going to give me x squared plus xh, which adds up to plus 2xh, and then plus h squared. So that's FOILing. X plus h squared gives me x squared plus 2xh plus h squared. Next, I have plus 2 times x plus h. I'm distributing here to get plus 2x plus 2h, and then I carry down my minus 1. All right, let me just draw a little boundary here to separate part A from part B. So for part B, now I want to calculate the numerator, f of x plus h minus f of x. So f of x plus h is going to be this whole string from part A. Notice that there are no like terms to combine. I'm just going to copy that whole part over. X squared plus 2xh plus h squared plus 2x plus 2h minus 1. And now I want to subtract f of x, which means subtracting x squared plus 2x minus 1. All right, so when I distribute, this gives me minus x squared minus 2x and plus 1. And then I carry down my other terms, x squared plus 2xh plus h squared plus 2x plus 2h minus 1. And now I can cancel stuff. I've got plus 1 minus 1, minus 2x plus 2x, minus x squared plus x squared. So looking at what I have left, I've got 2xh plus h squared plus 2h, and all my other terms have canceled out. Let me create a division line here. So for part C, I want to take my numerator that I just came up with in part B, which is 2xh plus h squared plus 2h, and I want to divide that whole thing by h. And you can see that h will cancel out of all 3 terms up in the numerator. If that's not easy for you to see, then go ahead and split this into 3 fractions. We're just dividing by one single term, one monomial. So I can split this up into 2xh over h plus h squared over h plus 2h over h. And then let's cancel individually. H's cancel here, so that gives me 2x. And then h squared over h leaves me with an h, so plus h. And then for my third term, the h's cancel, and it leaves me with plus 2. So 2x plus h plus 2 is my difference. All right, now something that I want to mention, just because as you guys can see, there's lots of room to make mistakes. If you make a little sign error, a little typo, that'll affect your whole answer. So 2 things that I want for you guys to check. One is, notice that when we do this minus f of x step, notice that every term from that minus f of x cancels out. Every term from minus f of x cancels out. If that's not true, then something went wrong. Go back and check your work, go back and check your signs. The other thing that I want you to notice is at the end of this, when we do this divide by h step, notice that h is entirely absent from our denominator at the final answer. So we just got a 3. We didn't get 3 over h. If I did, I would say, ooh, something's wrong. 2x plus h plus 2, there's an h in my answer, but there's not an h in the denominator, okay? So if you had mistakenly, for example, taken this guy and just canceled the first h that you see and gotten 2x plus, h squared over h plus 2h over h or something like that. Actually, I don't think anybody would end up with that. But if you had written that as your final answer, you would see these h's in the denominator, and that would be a red flag for you, okay? So minus f of x, all terms cancel, and then make sure your final answer doesn't have that h in the denominator, just as 2 quick checks that you can do.